Okay, in the stock market, there are basically two kinds of returns that you can get. You can get a capital gain, which is just what you purchased it for minus what you sold it for, right? So in this scenario, it's $3. It's a $3 capital gain because you bought it for 100 and you got 103. There's another idea of a dividend. If a company pays a dividend, you get that dividend yield based on what you paid for it. So the dividend in this scenario is $2, and then the dividend yield is 2% because you get $2 based on $100 that you paid for it. Same thing when you sell the stock at the end, you get a capital gain of $3 and a percentage capital gain of 3%. And those added together, you just get a 5% total return. You add those two together. It goes both ways though. So let's say that this stock that you purchased went down in value. So you get a negative $2 return and a negative 2% capital gain. It's a capital loss, but then you still get a $2 dividend and then a 2% yield on that, which you just get a $0 total return. Next, I want to talk about so this is how to calculate discrete returns in Excel. I have a set here of SPY ETF adjusted close values in reverse chronological order. It's pretty easy. You just equal sign, open parentheses, you get the new value minus the old value divided by the old value. And then in Excel, I can copy this, highlight all these with Shift arrow, Control V to paste all those. So I get a per month return, right, for this ETF, this stock. And so annualized, it's the same idea, only it's not just 1 month period to the next. It's the whole 12-month period. So the new price minus the old price divided by the old price, 26.3. And then so if I wanted to add up all these monthly returns, it does not equal the annualized return. But this discrete return is helpful because it's easy math to do and it's intuitive and yeah, it's helpful later on as well. But there's another way to do these returns, to calculate these returns with a continuous return. And what we're going to use in Excel, again, I have my SPY in reverse chronological order with adjusted close prices. All it really is equals ln, which is the natural logarithm function. We're giving it the new price divided by the old price, and that gives us a monthly return. Again, copy, highlight these down with Shift and down arrow, Control V to paste. And then again, we can do this same thing with annual amounts. So I'm giving it the new price divided by the old price. So that gives me 23.29. What's cool about this is if I add up all of the monthly returns, it gives me the annual return. So that's really cool and kind of it's a pro over the discrete return. This is a little bit harder to understand, but this should be a good thing to know for calculating your returns. Okay, so now I want to turn to averages. So I have, again, my SPY adjusted close prices in reverse chronological order. I already have my discrete and continuous monthly returns calculated, but I want to know what the average is, right? So everybody probably learned this in grade school. The simple average is just the sum of the values divided by the count of the values, right? So the sum of all those discrete monthly returns divided by 12, and that's 2%. And so I'm just going to copy this and put this over here. It's the same function. It's the same formula, just applied to this range now. Excel also has an average function that you can use that does the same thing. Now this is 2% and 1.94%. It's the same thing. For a geometric average, this is related to the discrete return. And this is very important, and it's a little bit harder to math to understand. I want to add 1 to each one of these monthly discrete returns. Then I get this 103 kind of funny value, and then if it's a negative number, it's 97%, right? To get the geometric or compound kind of like growth rate, I want to multiply all of those geometric values together with the product function in Excel, and then raise that to the power of 1 divided by 12. There are 12 periods in this, and so we're raising it to the power of 1/12. Whoops. And then subtracting 1 off of the end of it to get our monthly geometric average, right? And there's another way to do this. It's basically the same thing as the discrete, only we're using this idea of taking it to the power of something, right? So it's the new price divided by the old price to the power of 1/12, or like the number of periods between the two dates minus 1, and that gives us the same thing. And just to build a little bit of intuition with this to the power of whatever thing, so I mean, we all probably know what 6 times 6 is, not 66. 6 times 6 is equal to 36, right? Or same kind of notation here is 6 to the power of 2 just means 6 times 6, right? Well, we can go backwards and we can do a square root. The square root of 36 is 6. Okay, and that's what this radical kind of means, right? Well, we can also do something else. We can take 36 to the power of 1/2, which is kind of a funny way to look at it, but it's the same thing as 6. So taking the power of 1/2 and a square root is the same thing. And here's our little picture of it right here. This radical is like an imaginary 2 kind of right here. And this is something you can do for anything. You can plug in whatever number here in the denominator that you want. And we did that with this geometric mean with the number of periods. So that's just building up a little bit of intuition with that. The compounding. Okay, so this is the next thing I want to talk about. I already have all of my discrete returns, my SPY adjusted close prices in reverse chronological order again, and then I have our discrete, geometric, continuous, and then I have the averages right here. And what I want to know is which one of these average monthly amounts is going to get us from this beginning amount to this ending amount, right? And so what I can do here is I'm just going to use our future value formula. This is just a mathematical formula. And we're going to take the beginning price times so open parentheses, 1 plus our periodic rate, monthly rate of 2%, to the power of 12. 604.79. That is not the same as the 601.82. So let's see if we can get it with this one. Equals beginning price times 1 plus this geometric average to the power of 12. Okay, so this one does get us to the 601.82. That's good. I think that's something to note, right? And then on this continuous, what's cool about this continuous one is like I showed you on the continuous tab over here, this 1.94% is just the simple average of all of the monthly continuous returns. Okay, so that's easy math to do. It's just the hard math is kind of front loaded. So this 1.94%, and I guess this is the future value function. There isn't really a future value function in Excel for this, but we know the mathematical formula, and it's equal to, so the present value times EXP, right? And this EXP function, I'll explain it here in a second. We're going to feed it this monthly continuous return times the number of periods that we want to compound by 12. And that gives us the 601.82. So, well, I mean, what does this mean? That we want, when we're looking at stock market returns, we want to be looking at the compound annual growth rate or some kind of continuous growth rate to know exactly what our prices are going to be. It's a more accurate kind of way to look at it, in my opinion. And then this discrete is helpful on like really short term, like thinking, and it is related to the geometric average. So we want to know how to do those. It's just, this is maybe not as helpful in the long term. There's also a couple functions that we can use for this. It's equals FV for future value. We give it the rate, and then we give it the number of periods, which is 12. Give it the number of payments, and these are periodic, like interim payments. For this example, they're 0. And then in Excel, we need to give the present value a negative sign if we want a positive sign, a result to this function. Enter 60479. So it's doing the same thing as the manual calculation that we did here, just in a function, Excel function. And then if I copy this and paste it here, we get the same thing. It's just doing the same thing that we did here. Something cool that I think goes along with this continuous compounding, it has to do with the number of compounding periods within a year, right? So like we're kind of talking about monthly compounding periods. So like every month you compound the rate of return. But in this scenario, in this continuous scenario, it is continuous, which literally means that it's continuously compounded. And this number right here, this 2.71828, is Euler's number, which is a mathematical constant like pi, right? So 3.1415 is pi, which is like I can't remember, I'll probably get it wrong, the ratio of a circle's circumference to the radius or whatever. This is a similar idea. This is like, I think like the limit or something. We're approaching the limit of compounding as of 2.718, right? And this number is used within this EXP function that we used in this cell right here. Notice it says returns E, which is this number, raised to the power of a given number, right? And so we just did the rate times 12, right? And that gave us our like kind of future value factor, right? Last thing I want to go over on this video is the holding period return. And this is like a little bit of a nice to know type of a thing. When you're looking at like Yahoo Finance, there are these SPY adjusted close prices, right? And this adjusted close price isn't a real value. It's adjusted for dividends, right? That happen during that period or whatever. It is helpful for our purposes to calculate discrete and continuous returns and average returns and stuff like that, but it's not real. So I just want to kind of approximate this with this holding period return idea, which is just basically your ending price plus any dividends, kind of like we talked about in the basics, minus the beginning price divided by the beginning price, right? So our discrete holding period return for this period would be equal to this new price plus the dividend, minus the close price from the last period, the old price, divided by the old price again. So it gives us 2.69%. And then for the continuous, it's something similar. It's equals to ln, and then I need to open another parentheses here. So we have our close price plus our dividend, and then close that parentheses, divided by the close price. So that gives us something similar, and it's taking into account the dividend, right, in this dividend column. And so what I can do here is I can just copy and paste these down. Since again, I have it in reverse chronological order, it's easy to calculate all these at the same time. Here I can, I can do something similar for like an annualized return. I'm going to take the close price, the ending price plus, and I'm just going to assume that all the dividends happen at the same time at the very end of the year, which isn't exactly right. And then subtract the beginning price divided by the beginning price, or the old price. Okay, 26.083. Okay, and then this is from our other tab that is using the adjusted close price for our annual amount. So it's pretty close. Same thing for the continuous return. I'm just going to do ln, open parentheses, this ending price plus all of the dividends. We're just, again, assuming that they're all happening at the end of the period. divided by the old price. Whoops. Yeah, I want the, okay, 23.17. So that is similar. That's really close as well. And that's just this holding period return kind of idea, which encapsulates the capital gain and the dividend yield at the same time. And we're calculating all that and getting like we can do averages and stuff like that with this as well. So